Well, we have this question here, question 5. Given f of x is equal to a quarter to the power of x. And in the previous video, we did question 5.1, 5.2, and 5.3. In this video, we're going to start from question 5.4. The question says, hence or otherwise, sketch the graph of f minus 1 in your answer book. Clearly indicates all intercepts with the axis. All right. I'm gonna move this over here, and then I'm gonna write here question 5.1. So we need to sketch f minus 1. Okay. Okay, sketch. Or graph, just graph. F minus 1 graph. All right. The question says we need to indicate all intercepts. Remember, in the previous video, we said the line must be symmetric about the line y equal x. Okay, but before I do, let's first find the intercept. F of f minus 1 was found to be equal to negative log of x to, no, okay. I can use any of them. Let's just use log of x base iota. So log of x base iota. That was f of x. F minus 1, I mean. F minus 1 of x is log x base iota. So if we need to find the intercept, I'm going to write here y equal to log of x base iota. So to find the intercept, we can start by finding like the x-intercept. Okay, x-int means we're going to make y equal to 0. So this will be so it's going to be, we make y 0, so it's going to be like equal to log of x base iota. So we sub y by 0 there. This means this means x equal to a quarter to the power of 0 according to the log formula. So the base will be equal to the power of 0. X will be equal to the base to the power of 0. And then this means x is equal to 1. So the x-intercept is 1. Now for the y-intercept, y-int means we're going to make x equal to 0. Now let's see. Here it means we're going to do y equal to log of, okay, y to log x base 4, we sub x by 0. So this means log of, we sub 0 here for x. But now this is not acceptable because logs don't take 0 or negative numbers. Okay, logs can only accept the values of x that are greater than 0. By definition. Okay, logs can only accept not equal but greater than 0. Yes, greater than 0. So there is no intercept, meaning by the horizontal line we have an asymptote. Now let's draw this thing. Well, we have question 5 here that says f of x equal to a quarter to the power of x. Now, in the previous video, we did question 5.1, 5.2, and 5.3. Now we're going to do question 5.4. That says, hence or otherwise, sketch the graph of f minus 1 in your answer book. Clearly indicates all intercepts with the axis. All right. Now I'm going to move my screen. I put over here. Let's just split. So we have y equal to 5.4. No. So it's question 5.4. Says we need to sketch the graph of f minus 1. Okay, f minus 1 graph. All right. because we need to indicate, okay, obviously to do the graph, we need to find the intercepts, okay, and some important things like asymptotes, if there is. So now let's see. F minus 1 was given, f minus 1 of x was given by log of x base 4, okay, or negative log of x base equal to f minus 1 just y, so y equal to log of x base 4. Now, to do the graph of the logs, we need to determine the intercepts, okay? Let's first talk about the x-intercept. So x-int implies that y equal to 0, okay? So meaning I'm gonna write here equal to log of x base equal to. So I'm gonna substitute y by 0 there. Now it's like saying log x equal to 0. By definition of the logs, means x will be equal to the power of 0, okay? Because let's just to the power of 0, so which is just 1. Now that we find the x-intercept, we also need to find the y-intercept, okay? If there are, let's see, y-intercept means that x is equal to 0, okay? So we will then write here y will be equal to log of x base equal to will become then y will be equal to log of x, which is now 0, okay? Now, it is important to note that the logs function cannot accept values that are 0 or lesser than. So logs can only take values of x that are more than 0, okay? That's the definition, the domain of logs. So that's the domain of logs, okay, of logs function. Logs don't accept values that are 0 or less. You can press the calculator, you're gonna get an answer error. So there are no x, so therefore we say no, therefore no y-intercept. Okay. Now I want to draw the graph of. Okay, let's first draw the xy coordinate or the Cartesian coordinate. Draw the Cartesian coordinate. I did draw my y-axis. Now I draw the x-axis. See the x-axis passes through here. So this is the y-axis, and then the x-axis. Then comes the tricks. These are ways we can do that. We can use the previous information to draw this. Okay, I know that f of x and f minus 1 of x, are both symmetrical. They're both symmetrical on the line y equal x. Okay, on this line here. I'm going to draw the line y equal x. The line y equal x splits the first Cartesian, the first quadrant into a half, okay, 45 and 45 degrees, because both will make 90 degrees. So it's a line that will pass through the origin and then make an angle of 45 degrees. So this line. This is the line y equal x. Now, okay, I do know about f of x because f of x was given to be a quarter to the power of x, right? And this is the same thing as to say 4 to the negative x. And those type of of exponential function is a decreasing exponential function. It starts from up and down, okay, and then it passes through also the number one. Those are the general form we need to know, because to draw this graph, you need to know the general form of notes. You need to know the general form of functions, of the graph of functions. Okay, you may not need to start over here to draw this graph, but if you do know already that, okay, log functions will look have this form. For logs, for instance, I know that logs function has this form. It goes from down here to this. Okay, those are log function. But now when I look at my function here, this is the function that I have was, I say base 4, I meant a quarter, it was a quarter here. But it didn't change anything in the calculations, okay? It won't change anything in the calculation here. Yes, a quarter, this is, as we calculated earlier, it is the same thing as negative log of x, okay? Log of x base a quarter can be written as negative log of x base 4. So this is the same function, but the same function as this one, but reflected on the x-axis. So the function would, this function won't look this way, but it will then look the other. It will look like it will be reflected. So as it was like this, let's make it like that. So now it will be reflected. So on the x-axis. So instead of it increasing, it will also descend. It's going to be decreasing. Okay. So the function will be on a draw a rough sketch. It's going to be something like that's like up like this to 2 and passes through 1 here, the x-intercept. Okay, or maybe if you want to make sure, you can also do that by first finding the graph of f of x, which was 4 to the negative x. We do know that exponential function with a negative exponent, like the negative x, like this, it decreases. Okay, so we can draw this graph. We can start by drawing this graph like that, decrease, and it passes through 1 and goes like this. So this is the general form of exponential function with a negative x as exponent. You see, so it comes up, down, okay, passing through 1. Now these two, we can notice that the two graphs here, the yellow and the green and the orange graph are symmetric, all at this line. Okay, so this is the same as that part. I hope it's clear. Thanks.